All right, in this video, we are going to be talking about exponential differentiation and integration, especially whenever your base isn't e. So looking at number 5 and number 6, what we're going to be doing is using properties of logs to find the derivative of 2 to the x and then to find the derivative of 3 to that lovely thing right here. And then, of course, we will generalize it in terms of a to the x and then a to some function right here using chain. So for number 5, we are going to have ln of y is equal to ln of 2 to the x. Ln of y is equal to x ln of 2. And then we are going to take the derivative. So 1 over y prime is equal to ln of 2. And then y prime is going to be y ln of 2. And then if I were to go ahead and rewrite y to be our original function, which is 2 to the x ln of 2, you see that this right here is going to be my derivative. We're going to see something special in terms of 5 and 6. Hopefully you saw it. Number 6, we are going to be using our properties again. So we have ln of y is equal to ln of 3 to the 4x squared plus 3x minus 1. Using my properties, that's going to be 4x squared plus 3x minus 1 ln of 3. And then I am going to take the derivative of this. So I have 1 over y prime. Ln of 3, think of it as a coefficient because it's a number. So now we have 8x plus 3, ln of 3. And then y prime is equal to y, 8x plus 3, ln of 3. And then we know that y is the same thing as 3 to the 4x squared plus 3x minus 1. 8x plus 3, and then ln of 3. Hopefully you saw with these two examples right here that we're still going to have our y. So 2 to the x and 3 to the 4x squared plus 3x minus 1. So if I have a to the x, we're still going to have a to the x, but then we're going to plop a ln of whatever the base is. So your derivative here is going to be a to the x times ln of a. Same thing with number 6. We're going to have a to your function times ln of a. But then remember that we have to use chain. So that's how we got the 8x plus 3, which means that we're going to have u prime of x, whatever that is right there, using our good old chain. So for example here, if I were to do number 8, where I want to find the derivative of 3 to the cosine of 3x to the 4th power, I'm going to have 3 to the cosine of 3x to the 4th. I'm going to have ln of 3. And then I'm going to use chain to find the derivative of cosine of 3x to the 4th. So that's going to be negative sine 3x to the 4th. And then I'm going to have to chain that, which is going to be 12x to the 3rd power. So this right here is this lovely thing right here. Lots of fun. Same thing with number 7 here, where we want to take the derivative, but we have to use quotient. So I'm going to have low the derivative of high. So I'm going to have 3 to the 2x times ln of 3 times 2, because that is my chain for 2x, minus high. D low is going to be 1 all over low square. And you would just keep it like that. 15 and 16 is fun. So looking at 15, we want to find the equation of the tangent line of 5 to the x minus 2 at x is equal to 2. So I need to figure out what my point is, and I need to figure out what my slope is. Well, my point, it's 2 something, and then my slope, I gotta take the derivative of that. Well, to find my point, I'm gonna go ahead and plug in 2. That's just gonna be 1. And then to find my slope, I gotta take the derivative of that. So 5 to the x minus 2 times ln of 5 times 1, because chain of x minus 2 is 1. And then I'm gonna plug in 2. So that's just going to give me ln of 5, because 5 to the 0 is just 1. So you have your point, you have your slope. Go ahead and put everything together. You have y minus 1 is equal to ln of 5, x minus 2. This would be your equation of the tangent line. 16, you are going to use a product. So we have... let me write that. We have first times the derivative of the second plus second times the derivative of the first. And that would be your lovely derivative there. Lots of fun. Same thing with 13 and 14. You should be able to do this on your own now, knowing the rules. In the next video, we are going to take a deeper dive into exponential integration. So now if I have 2 to the x, what happens? And if I have 3 to the sine of x times cosine of x, what happens there? So that's going to be our next video.